So we are starting a new chapter. We're completely shifting gears, and we're starting meteorology. As you can see on the top of the packet, it says meteorology part 1. So if you can assume I'm telling you there's a part 1, there's another packet for part 2. So we're gonna actually start with these 5 boxes on the top of page 1 in your packet. And first, actually, by yourself, in those 5 boxes, I want you to tell me, what do you think meteorology is in box number 1? Then in box number 2, tell me what a meteorologist is. Number 3, what is weather? Number 4, what is the atmosphere? And number 5, where do you think most of the energy on Earth comes from? So those go in the top 5 boxes there. So go ahead and take a few minutes and tell me what you think each one of those means. Again, this is what you think. So this is not a test, but everybody needs to participate. They're just answering the questions in the box.
Gotcha.
So we don't need to rewrite the questions or anything. Just tell me what you think the answers are. All right, I'm gonna give you, because I see some empty boxes, I'm gonna give you about 3 minutes, maybe 4 or 5 minutes. We'll see how long it takes. Go grab a partner or someone to talk to, or 2 or 3 other people to talk to, and go fill in your 5 boxes. So take some time to go find someone to talk to. Give me more than one person to tell me what you think goes in those 5 boxes.
Oh, yeah.
Quiet. Not funny. Well, what's the guy? The guy on TV.
That was, I almost said it's like the weather. I think easy, buddy. Don't recall putting my partner.
Do you think you guys can handle learning from where you're sitting right now?
Yeah.
Okay, do not make me regret this choice. You don't think so? I know so too. All right, so let's start with what do you think meteorology is?
Study of weather and atmosphere.
All right, meteorology. Did anybody say anything different besides the study of weather? Weather and air temperature. Nobody said the study of meteors? Okay, good. At least somebody did. Yeah, you're not right. But somebody always says that. So let's, if you don't already notice, below the boxes is a spot for the actual true definition. So meteorology is the study of Earth's atmospheric changes. In other words, it's the study of weather. So that goes right where it says meteorology. We're about halfway through the front page there. All right, everybody good with those two bullets, or do you need another second or two? Okay. Yep, I see you. Keep going. What? You before. Everybody enjoying social hour back there? So, what's a meteorologist?
Oh,
What's a meteorologist?
the guy on TV that studies weather.
The guy on TV that studies the weather, not just a guy, but anybody. It's a scientist who studies weather. Nope, it's not. No. I do want to, okay, please do not make me regret my decision to make you go back to your seat. I do want to point out, it's not just any of the people on TV that are doing the weather. They will designate some of the weathermen or weather people on the news. Some of them are called meteorologists and some are just weather reporters. The meteorologists are actual scientists. They went to school and learned the science of meteorology. Whereas some of the other reporters that report the weather went to school for journalism and happened to get a job as reporting the weather. There's nothing wrong with either job. I just want to point out there is a difference. So on TV, I know Channel 4 advertises that everybody's a meteorologist. So all of the people on Channel 4 can tell you and understand the weather. They don't just tell it to you, but they actually know the science behind it. Where there's other weather reporters, I know, for example, Kevin O'Neill is one of them. I think he's on Channel 2, okay? He just is a journalist who got a job reporting the weather. Doesn't make him any less important. He just can't really explain why he can just report what someone else tells you. Two different jobs, not one better than the other, just two very different jobs. Just wanted to point that out to you guys. So then the next question I guess we need to have is, well, what the heck is weather? Yeah, exactly. It's the weather outside. Yeah, it's snow. That's an example of some weather. It's, oh, where did weather go? There we go. Weather. It's the short-term condition of the atmosphere. We know this, that it can change very quickly within days, hours, or even minutes. Okay. Pull it together or leave. I didn't need the round of applause.
Yeah.
Then we definitely didn't need it.
Gotcha.
So since weather has so much to do with the atmosphere, we have already briefly discussed the atmosphere earlier this year when we were talking about the layers of the earth. So the atmosphere, hydrosphere, lithosphere. But we're going to get into some more details about the atmosphere this chapter. We're going to be spending actually quite a bit of time on talking about the atmosphere this chapter. So to start off with, well, what the heck is the atmosphere? It is one of the layers of the earth. And what is it made out of? What'd you say? Oxygen. Is it only? No hydrogen in the atmosphere. Nitrogen. Yep.
Carbon dioxide.
There are, yep. So the atmosphere is the shell of gases that surrounds Earth. That's the very basics. That's what you've learned up until this year. But we are taking it to the next level, and it is divided into layers based on temperature changes within the atmosphere. All right, so again, with your partners, I'd like you to answer the last bubble there on the bottom of the page. So what is the difference between weather and meteorology?
Yeah.
Answer that last bubble. What is the difference between weather and meteorology? Meteorology is the study of energy. So is there much difference? Yeah. There you go. Weather is the short-term condition. It is whether it's raining, snowing, sleeting, hailing, temperature, humidity, pressure, cloud cover. Meteorology is the study of that. The last bubble I had you answer up top, though, that one was a little different. I did ask you, where do you think most of the energy on Earth comes from?
The sun.
All right, we already know most of that. All right, good. So this next part's not going to be new to you. So for the last 15 minutes of class, we're going to read page 2 and do page 3. That is the plan for the rest of the class. I'm going to try to get into one more thing. We'll see how far we get. I have not decided yet if we're going to have homework. So what I want you to do is go to page 2.
On it.
Page 2, like I said, is a reading that talks about energy in Earth's surface. We are going to read that page together. But while I'm reading it, if you want to look over to page 3 to see what material you're going to be looking for in page 2, we're going to be looking for what is internal energy and what causes it. We're going to be looking into external energy and what it's affected by. And then we're also going to be looking for a random vocab word, insolation. We'll do the compare and contrast together. So again, definitions of internal and external energy, causes of internal, and what affects external. So page 2, we're going over to the reading. Energy in Earth's system. Internal energy refers to energy that comes from inside the Earth. There are 2 principal sources of Earth's internal energy. Some of the energy is left over from the formation of the planet 4.6 billion years ago. In addition, there is energy from radioactive decay. Some large atoms, such as uranium, are unstable. They spontaneously break down into more stable substances, such as lead. This slow process releases heat energy. So I think I actually failed to mention that last chapter, that not only does radioactive decay turn uranium into lead, that process gives off heat energy. I didn't tell you that last chapter. Anyway, keeping going with the second paragraph there. Sunlight is the Earth's primary source of external energy. The sun is made up of mostly hydrogen. Under extremely high heat and pressure within the sun, hydrogen nuclei join during nuclear fusion. Solar energy moves to the surface of the Earth mostly by convection currents. From the surface, energy radiates into space as electromagnetic waves in sunlight. Radiation is the transfer of energy in the form of electromagnetic waves. It is the only way that energy can travel through space. Radiation travels at the speed of light. In fact, it takes about 8 minutes for solar energy to reach Earth. Earth receives only a tiny portion of the energy given off by the sun. However, this energy powers hurricanes, tornadoes, and other dynamics of the atmosphere. Solar energy that reaches Earth is known as insolation. This word can be thought of as a shortened form of the phrase incoming solar radiation. The amount of insolation depends on several factors. First, the angle between Earth's surface and the incoming rays of sunlight, the angle of insolation, affects how much solar energy reaches Earth. If the sun is directly overhead, the angle of insolation is 90 degrees, as if the sun were near, whereas if the sun is near the horizon, it has an angle closer to 0. The angle of the sun changes with time of day and with the season. When the sun appears high in the sky, the light is spread over a smaller area and it reaches Earth's surface and results in energy being concentrated at that location. Another factor that affects the amount of insolation is the length of time the sun is visible in the sky, or the number of hours between sunrise and sunset. This is known as the duration of insolation. The longer the sun is in the sky, the more insolation that can reach Earth's surface. Finally, the amount of insolation that reaches Earth's surface is controlled by how much atmosphere absorbs every day. For example, on a cloudy day, less insolation is received by the Earth than on a clear day. So again, from the reading, you were looking for a definition of both internal and external energy. You were looking for the two causes of internal energy and the three things that affect how much external energy we receive. Do you want to try to do those on your own, or you want to just start up right now together? Together, on our own. A little bit of both. How about we do this? Why don't you go in the reading and underline them? So if you don't want to write the wrong thing, that works for me. Why don't you go find the definition of both internal and external, the two causes of internal, and the three things that affect the insolation received by Earth. So take a few minutes and go just underline those. All right, what'd you find for internal energy? What is it? And that one is energy that comes from inside the Earth. And there are two different causes. What were the two? And radioactive decay. So the two causes are radioactive decay, that's the half-life stuff. And the second is heat left over from the forming of the Earth. What was external energy? Solar energy, energy from the sun. If you know that solar energy means from the sun, you do not need to write that. There were three things that affected how much energy we receive from the sun. Not convection currents. Convection currents was how the energy got from inside the sun to the surface of the sun. Nope, radiation is how the energy travels from the sun to us. Nuclear fusion is where the energy comes from on the sun. All of those are great answers, but none of them answer the question that said, how much energy do we receive from the sun is affected by three things. What? Angle of insolation was the first one. So clearly these need to be written out pretty much word for word in those boxes. Angle of insolation is the position of the sun in the sky. So it truly means how high is the sun. The higher the sun, meaning directly overhead, more energy. The lower the sun, less energy. All right, so if angle was 1, what's another one? I couldn't hear you up. Yep, which is officially called the duration. Either explanation would have been great, or the vocab word. Duration of insolation means how long the sun is above the horizon, meaning how many hours of daylight. So if the sun is out for 15 hours, like it is in the summer, you can get more energy from the sun. In the winter, when the sun is only out for around 9 hours around here, you get less energy from the sun. And did anybody catch the third and final one then? It's basically, it's called atmospheric transparency. It's the amount of solar energy that is absorbed by the atmosphere, or how much sun can get through the sky. In other words, today, we are not getting much solar energy because we have 100% clouds out there. And one last thing that we need to do is the word insolation. Now, first of all, how many of you thought I was mispronouncing it every time I read it? It's not insulation, like the pink stuff you put in your attic. It's insolation. No, it sounds similar, insolation or insolation. Yeah, it is solar energy that reaches the earth. That's the official definition. But I think just this phrase, incoming solar radiation, is a good enough explanation. And you can actually see where the word comes from. So insolation comes from in solar ation. So insolation is incoming in solar solation, radiation. We're gonna stop here. No homework. You will have homework tomorrow. It won't be a lot. A few questions. Remember, if you want to do test corrections, you have until Monday the 13th.